So I think you can see the screen. So last week we did about multiple access techniques. So last week, right? Duplexing. You should never confuse between duplexing and multiple access. Duplexing, multiple access. එක අතර පටල ගන්න එපා. Duplexing means now in the beginning of the communication systems when you study, we always study about the simplex communication, duplex and half duplex, right? So duplexing means the technology associated with communicating between two ends at the same time, right? How do you communicate between two ends at the same time to the both directions? So that is duplexing, right? Duplexing and multiplexing and multiple access. Don't confuse between the concepts, okay? Right, so the duplexing techniques we did about frequency division duplexing and time division duplexing. And if in the exam paper, if you are asked to write what is frequency division duplexing, please try to draw the diagrams whenever possible, right? So in the slides, I have included the diagrams. So always try to draw the diagrams whenever possible. That way, your marks, you will better be able to explain properly. Instead of writing 1,000 words, you can draw a diagram and show it. You can write 1 or 2 sentences and draw the diagram, then your answer is complete. So always try to remember these diagrams. It's easy, right, for you. Then time division duplexing I discussed. Multiple access techniques. What are the multiple access techniques? Now multiple access techniques come into play when we have multiple users that need access to a common uh, shared medium, right? So when we have multiple users who need access to common shared medium, the multiple access techniques come into play, right? Then here the spectrum is shared, right? Achieve high capacity. To achieve high capacity means to accommodate multiple users, right? High capacity එකක් achieve කරනවා කියන්නේ users ලා ගොඩකට accommodate කරන්න පුළුවන් විදිහට අපි system එක define කරනවා, design කරනවා, right? So we can use multiple access techniques to achieve high capacity to accommodate multiple users to share the common resources or share the limited spectrum. Okay, so multiple access techniques are very important. So we discussed about a lot of multiple access techniques, random access techniques like CSMA, CACD. Now these are for wired multiple access, right? And these multiple access techniques are for wireless, FDMA, TDMA. Now we have to discuss about SSMA, spread spectrum multiple access, CDMA and SDMA. මේ තුන අපිට කතා කරන්න තියෙන්නේ. මේ දෙක අපි කතා කළා. FDMA and TDMA. Okay. So what is FDMA again? FDMA means using multiple frequencies. This is, if you are asked to draw, write what FDMA is, you can explain it in a few words like this using these points, right? In FDMA, we divide the frequency dimension into several non-overlapping frequency bands, right? And individual users are assigned with different frequency channels, right? Individual channels. So this is how you can explain it in 1 or 2 sentences, and then you can draw this diagram. So when you draw this diagram, it's very easy to comprehend that you have understood the concept. Now in this diagram, how do you draw it? We have through 3 axes. You just don't draw it for the sake of drawing. මේක අඳින්න ඕන නිසා අඳින්න එපා. මේක හරියට අඳින්න ඕනේ, right? So here this is the frequency axis, chord axis, time axis. So these 3 axes can change. නේද? ඔයගොල්ලෝ ඕන frequency axis එක මෙතන දාන්න පුළුවන්, chord එක මෙතන දාන්න පුළුවන්, time එක මෙතන දාන්න පුළුවන්. Anyway, you have these 3 parameters, 3 axes. Axes තුනට parameters ඔන්න ඔය තුන තියෙනවා, right? Then we have the this kind of a block. Now here, what is happening is frequency axis is divided. Okay, frequency axis is divided. Yes, you can ask any if you have any questions.
मैडम मैं मतलब दिन पावर कट मैडम मैं फोन नहीं
Oh,
ඇවිල්ලා ඉන්නේ ඕෆ් එක තමයි on කරන්ට් එක.
මේ ඔගොල්ලෝ මේ රෙකෝඩින් එකක් කවුරු හරි කරනවා නම් ෂෙයා කරගන්න නැත්නම් මේ attendance දාන්න chat එකට. හරිද? හරි. Okay. Now here, now the frequency axis is divided into different channels. Ne? Channel 1, channel 2, channel 3, channel 4. Likewise, frequency axis is divided, but the chord axis is not divided. Time axis is not divided. See, there is no change in the time or the chord. And everyone else, please put your registration numbers in the chat to mark the attendance. Okay, yours is number 2. Okay, right. So I'll take attendance at the end of the lecture. After finishing the multiple access part. Multiple access codes ඉවර කළා මම attendance ගන්නම්. If anybody is not able to tell your attendance, put your registration numbers in the chat. Okay. Okay, so here now time axis is not divided, chord axis is not divided. Only the frequency axis is divided. Understood? The frequency axis එක තමයි බෙදිලා තියෙන්නේ, chord axis එකයි time axis එකයි බෙදිලා නැහැ. So you should, you can practice how to draw this diagram, right? So this diagram explains that using the same chord and time, but using different frequencies, you can transmit data to different users. නේද? users users අතර data transmit කරන්න පුළුවන් වෙනස් frequencies පාවිච්චි කරලා හැබැයි එකම වෙලාවේ එකම code එක. තේරුණාද? So this is frequency division multiple access. Try to remember. Now don't get confused with the figures. Okay, always frequency division multiple access and time division multiple access, they are different from each other with the axis. now මේ axis එක බෙදෙන විදිහ අනුව තමයි මේ දෙක වෙනස් වෙන්නේ. හරිද? frequency axis එක මෙතන බෙදෙනවා frequency division multiple access වල. in time division multiple access, see, the time axis is divided, right? Time axis is divided. Now each user is allocated with a different time slot. හරිද? හැම userම allocate කරලා තියෙන එක time slots වල. But the frequency is same and chord is same. Okay, chord is same and frequency is same. See, chord is represented by this side, frequency is represented by this side. Both are same, but the time axis is divided into different time slots. Okay, right. I hope you understood that. Then we have incorporated the time division duplexing and multiple access techniques together. නේ FDMA වල TDD කොටස් technique එකක් තියෙනවා, FDMA FDD technique එකක් තියෙනවා. So you can read this further, and if you have any confusions you can ask me. Okay, time frame. Okay, TDMA frame. This particular frame has 3 segments, main segments. One is the preamble, right? Preamble has different addressing information. Then information message. This is the message part. This is the real information. This is where the real information lies, right? And then we have the trail bits. Now we use trail bits for error correction usually. හරිද? අපි error correct කරන්න තමයි ගොඩක් වෙලාවට trail bits පාවිච්චි කරන්නේ. ඊළඟට මේ තියෙන්නේ සාමාන්‍යයෙන් අපේ වැදගත් වෙන message එක, right? Preamble is used for this is the header information. මේ frame header එක තමයි preamble එක කියලා කියන්නේ. මේකේ තියෙනවා එක එක addressing information and other stuff. Okay, the frame type, right? Addressing information, those kinds of stuff are stored in the preamble. Then we have a information message, and this message is divided into different time slots. නේද? මේ information message එක තමයි අපි එක time slots වලට බෙදලා තියෙන්නේ, which are intended to different users. නේද? එක එක userට මේ එක time slot එක තමයි allocate කරලා තියෙන්නේ, right? Now when you expand one time slot, again in that time slot you have guard bits, the synchronization bits and trail bits. Okay, in one time slot you have the data, information data, actual data. Then you have guard bits. Why do you need guard bits? Guard bits are ඕන වෙන්නේ මොකද? When the, I mean, it will avoid two time slot to overlap. When during transmission it will avoid two time slots to overlap. නේද? time slots දෙකක් overlap කෙන එක නවත්තනවා මේ guard bits තියෙන එකයි. දැන් මෙතන මේ time slot එකෙන් ඉවර වෙලාම අනිත් information data එතනින්ම ඊළඟට පටන් ගන්නකොට ටික දුරක් ගියාම මේ දෙක overlap වෙන්න පුළුවන් due to the effect of noise. If the information I mean, let's say the second time slot ends with the information data and third time slot starts with the information data. Then, with the other frame, without any guard bits, if there are no guard bits, these two slots can merge together during transmission, right? Due to the influence of noise and other factors, environmental factors, these two frames, TDMA frames can or two information data can merge together if we do not have guard bits. So that's the purpose of the information or the purpose of having guard bits. Okay. So anyway, this is the TDMA frame structure. Then data transmission for users of a TDMA system is not continuous but occurs in a burst. Due to this facility, subscriber transmitter can be turned off when not in use. This results in low battery consumption. Now it will occur in burst. That means transmission can happen in a bulk. Okay, so because of this, when it is not transmitting, the subscriber transmitter can be turned off, and that way the battery consumption will be saved. How is the battery consumption effective in TDMA transmission? Okay, right. Then let's move to the right. So we have incorporated TDMA, FDMA, FDD together. FDD is the full, duplexing, frequency division duplexing. FDMA is frequency division multiple access. TDMA is time division multiple access. Now you can see this is frequency division multiple access, right? මේ frequencies n ගානකට බෙදලා තියෙනවානේ. එතකොට frequency division multiple access එකක් මේ පැත්තේ. Then we have time division multiple access in this side. Slot 1, slot 2, slot 3 and so on. And then we have duplexing, right? This set is for the downlink path and this set is for the uplink path. Okay? So how do you represent this? Now this is FDMA, right? This part is FDMA. This part is TDMA. Okay, so these two together gives FDD. FDD because we have the downlink path and uplink path. Okay, so that is how FDMA, TDMA and FDD together is represented in this particular figure, right? So it is a hybrid multiple access technique along with duplexing. Okay, right. Then we have a special kind of a technique called spread spectrum technique. Have you heard about spread spectrum techniques before? Anyone? Now, spread spectrum techniques means they are mainly used for security purposes. ප්‍රධාන වශයෙන් පාවිච්චි කරන්නේ ගොඩක් secure transmission method එකක් විදිහට, right? So the initially these techniques were introduced as a very, it was initially used in military, right? It was initially used in military to, implement high security data transmission through wireless channels. Okay, high security data transmission. But how can it be achieved? The word spread spectrum means, spread means you spread it. Your spectrum is spreaded, right? So if you have a narrow band spectrum like this, once you use spread spectrum techniques, right? Your spectrum is, what is a spectrum? Collection of frequencies, a frequency band. Spectrum means a frequency band like this. This is a collection of frequencies, right? So you spread it like this. Your spectrum is spreaded like this. The power level is reduced, right? Power level is reduced, right? And then but you have expanded your information throughout this large gap of frequencies, so large band of frequencies compared to this narrow band. Narrow band එකට සාපේක්ෂව මෙන්න මෙහිම ලොකු band එකක තමයි මේ frequencies මේවා කරලා තියෙන්නේ. Can you give me a second? Right? Okay. Then okay. Now this looks like noise. Make a noise වගේ තමයි පේන්නේ because its power is very less. This looks like noise. So eavesdropping and jamming is very difficult in such spreaded spectra, right? When the spectra is spreaded like this, eavesdropping and jamming is quite difficult. නේද? Eavesdropping කියන්නේ මොකක්ද? Eavesdropping and jamming means you jam the signal. Jamming means you kind of interrupt the signal transmission. Neither jamming and eavesdropping. Eavesdropping means when the signal is transmitted, you somehow tap the signal and you listen to that signal, right? So in wireless channels, it's it's kind of when you use other techniques, it's not that difficult to tap a signal, right, or jam a signal. But by using spread spectrum techniques, we can avoid that, right? Now these are wide band signals now, right? So when you spread your narrow band signal, it becomes a wide band signal. Okay, when you spread your narrow band signal in a large range of frequencies, it becomes a wide band signal. Okay, so the main purpose of spread spectrum techniques is to provide more security for data transmission or information transmission. හරිද? තොරතුරු යවද්දී security එක වැඩි කරගන්න තමයි spread spectrum techniques පාවිච්චි කරන්නේ. Now here there are two techniques, two main spread spectrum techniques that are being used. First one is called the frequency hopping spread spectrum. The second one is called the direct sequence spread spectrum. පළවෙනි එකට කියනවා frequency hopping spread spectrum. Second one is called the direct sequence spread spectrum. So we'll go through what these two things are. Then we will come to the multiple access technique, which makes use of spread spectrum technique. හරිද? අපි multiple access techniques නේ මේ පාඩමේ කතා කරන්නේ. ඒතර multiple access technique එකක් තියෙනවා මේ spread spectrum පාවිච්චි කරලා කරන. අන්න ඒක ගැන කතා කරන්න තමයි මේ දෙක ඉගෙන ගන්න. Okay, that's why we study this part. Okay, right. And please, if possible, yes, many of you have renamed your attendance with the registration numbers. For those who are not, those who have not done that, please name your list, your neighbor, rename your list with your registration numbers. So, okay, so I can mark the attendance easily. Then, see here. Okay, here we have the narrow band signal with a bandwidth of capital B. We have a narrow band signal with a bandwidth of capital B. Then we do the spreading process, right? We do a spreading process. Now for this particular spreading process, we need a spreading code. Okay, I'll tell you what these are. We need a spreading code. A spreading code is nothing but a sequence of a digital data sequence. Spreading code එකක් කියන්නේ digital sequence එකක්. It is a random sequence. It is we call it as a pseudo random sequence of digital data. A pseudo random sequence. Okay, spreading code. So anyway, we put this spreading code and we do the spreading process, and after that the output is the spreaded bandwidth. Okay, spreaded band, which is spreaded along a wide bandwidth. This narrow band signal is spreaded throughout a wide bandwidth, and the bandwidth has increased now. Okay, bandwidth has increased. Okay, any confusion, any question you have to ask?
No, madam, we can continue.
Okay, then now I told you we have two types of spreading techniques. One is called the frequency hopping spread spectrum. The other one is called the direct sequence spread spectrum. පළවෙනි එක අපි කියනවා frequency hopping spread spectrum. The other one is called the direct sequence spread spectrum. So how do we do this? In frequency hopping spread spectrum, what happens? Now I told you, now we are sending this particular data sequence. Okay, we are sending this particular data sequence. Then we divide this sequence into, here we have divided into 3-bit categories. Okay, now this particular long sequence of bits is divided into 3-bit categories. මේ ලොකු sequence එක bit 3 එකට කඩලා තියෙනවා. හරිද? කඩලා each combination is allocated with a different frequency. So bit 000 combination is transmitted by 200 kilohertz. 001 is transmitted by 300 kilohertz. 010 is transmitted by 400 kilohertz. 011 is transmitted by 500 kilohertz. And likewise, these particular sequence parts are transmitted using different frequencies. Okay, so this is the this is the particular frequency assigning table. Okay, then we hop between these frequencies. Hop කියන්නේ මොකද? පනිනවා, right? So we frequently change the frequency. හරිද? යම්කිසි pattern එකකට frequency එක change කරනවා මේ අතර. හරිද? So now this is the frequency hopping spread spectrum. Now what is the importance of this one? Now I am sending 000 by 200 kilohertz frequency at one time, but I'm changing the frequency frequently, right? I'm changing the frequency, so then it will be a very secure method, so people can't easily track, right? If you send your information, but by changing frequencies time to time, it's difficult to tap, right? It's difficult to eavesdrop. It's difficult to jam නේද? එකට interrupt කරන්න අමාරු, jam කරන්න අමාරු, eavesdrop කරන්න අමාරු. හරිද? ඒක තමයි මේකේ ප්‍රධානම purpose එක in spread spectrum techniques. Okay, now here you can see now initially you send your particular data sequence using 700 kilohertz, right? Then you change it to 900, then again 300, 200. Likewise, there is no particular pattern, but you follow a pattern of your own. හරිද? ඔයාට I can cycle දමාන මේ pattern එකම තමයි repeat වෙලා තියෙන්නේ. But anyone other than the receiver does not know about this pattern. Okay, this pattern is this is only known by the transmitter and the receiver, right? So there is a pattern. There is no predictable. It is not a predictable pattern. නේද? predictable නෑ මේ 700 ඉඳන් 800ට යනවා නම් ඊළඟට 900ට යනවා නම් එහෙම වෙනවා නම් ඒක predictable pattern එකක් නේ. Then easily the eavesdropper, if he can listen to whatever the transmission frequencies for some period of time, then he can figure it out, right? He can figure out that okay, so after this 700 they are moving to 800, they are moving to 900, likewise. But this one is difficult to figure out, right? From 700 to 900, again to 300, again to 200, likewise. So there is no predictable pattern, but there is a pattern which repeats. නේද? ඒක repeat වෙනවා. නමුත් යම් කිසි කාලයක් ඇතුළත ඒක අල්ලගන්න ටිකක් අමාරුයි. හරිද? ඒතකොට security එක වැඩි මේ වගේ system එක, right? Security is high, right? So this is the at the end of the first cycle. Then again in the second cycle will begin the same way as the first cycle. නේද? පළවෙනි cycle එක වගේම තමයි second cycle එකත් ආයෙත් පටන් අරගෙන යන්නේ. නමුත් මේක ටිකක් වෙලා eavesdrop කරන් ඉන්න ඕනේ සහ track කරන්න අමාරුයි. හරිද? So we say that this is frequency hopping. Okay, frequency hopping spread spectrum. Okay, then when you draw it in what is the difference between frequency division multiplexing and frequency hopping spread spectrum? Frequency division multiplexing සහ hopping spread spectrum වල වෙනස මොකක්ද? Now frequency division multiplexing also uses different frequencies, but at the every time නේද? හැම වෙලාවෙම F1 frequency එක දිගටම තියෙනවා. හරිද? ඒ data F1 වල තමයි දිගටම යන්නේ. F2 වල ඉතුරු ටික දිගටම යනවා. F3 වල ඉතුරු ටික දිගටම යනවා. Likewise, there is no change, right? But in frequency hopping spread spectrum, it will change with time. Your data transmission frequency will change with time. කාලයත් එක්ක වෙනස් වෙනවා. හරිද? frequency hopping spread spectrum වල දැන් එක frequency එකකින් මම අද දැන් මේ වෙලාවේ transmit කරා නම් ඊළඟ time slot එකේ වෙන frequency එකකින් transmit කරනවා. ඊළඟ time slot එකේ තව frequency එකකින්. Likewise, there is a change in the frequency as well as it depends on the time slot, right? So there is a division in the time axis as well as in the frequency axis. Time axis එකේ frequency axis එකේ දෙකේම division එකක් තියෙනවා in frequency hopping spread spectrum. Okay, then direct sequence spread spectrum. Direct sequence spread spectrum එකේ මොකද වෙන්නේ? Now you can see the first here. This is the original signal you need to transmit. 101. 101 තමයි ඔයාලට transmit කරන්න ඕනේ. හරිද? Now bit duration of 1 is quite high, 0 is quite high, again 1 is quite high නේ. මේ one original signal එකේ bit duration ටිකක් වැඩි නේද? දැන් අපි මොකද කරන්නේ? මෙහෙම 101 විදිහට transmit කරාම මේ අපේ information signal එකම තමයි original data signal, right? So if a eavesdropper or if someone is tapping the signal, then he will directly get the data signal. නේද? data signal එකනේ ඒගොල්ලන්ට හම්බෙන්නේ. ඒතර තොරතුරු ටික තමයි කෙලින්ම ඒගොල්ලෝ tap කළොත් හම්බෙන්නේ. ඒගොල්ලන්ට හම්බෙනවා. තොරතුරු ටික කෙලින්ම හම්බෙනවා. කිසි කරදරයක් නැහැ. directly you have sent your information without any other alterations, right? So user can, you or any hacker or anybody who listens to this data or information can tap to it and access that information easily. But when you use a spreading code like this, මේ වගේ spreading code එකක් පාවිච්චි කළා. එතකොට මොකද වෙන්නේ? Now this spreading code does not have any meaning. මේ ස්ප්‍රෙඩින් කෝඩ් එකට තේරුමක් නැහැ. කිසිම ඉන්ෆර්මේෂන් එකක් මේක ඇතුලේ නැහැ. බලන්න මේ කෝඩ් එක රිපීට් වෙලා තියෙනවා. Right? Now it has been repeated like this. Okay? Now this is the code, spreading code. Code has how many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 bits. There are 11 bits and it has been repeated. Okay? For bit duration of 1, I use this spreading code. For bit duration of 0, I use the same spreading code. For bit duration of 1, I use the same spreading code. So original signal එකේ තියෙන bit duration එකකට එක ගානේ මේ spreading code එක පාවිච්චි කරනවා. හරිද? This if you ask how this spreading code is generated, මේ spreading code එක කොහොමද generate කරන්න කියලා ඇහුවොත්, it is a random way. It is generated in a random way, right? So we call this spreading code as a pseudo-random bit sequence. So you must have heard about pseudo codes, ne? The pseudo කියන එකේ තේරුම දන්නවද? Pseudo means it is not the actual code. Okay? Pseudo-random. Pretend කරන code එකක් මේක. Pseudo-random bit sequence. Spreading code is a pseudo-random bit sequence. It does not have any meaning. නේද? ඒකට එන කිසිම meaning එකක් නැහැ. නිකන් උගේ generate කරන code sequence එකක්. But that sequence should be same for each bit. නේද? මේ bit එකටත් ඒ එකම sequence එක. මේ bit එකටත් එකම sequence එක. මේ bit එකටත් එකම sequence එක. Now, when you encode this spreading code into the original signal, how do you do that? හරිද? මේ spreading code එක original signal එකට දාන්නේ කොහොමද? Now original signal is bit 1, right? Original signal is bit 1. In this particular bit duration, let's say the bit duration is t. නේද? මේ t කියන duration එක ඇතුලේ tb කියලා ලියනවා. bit duration, right? tb කියන bit duration එක ඇතුලේ මගේ spreading code එකේ bit duration එක ඊට වැඩිය ගොඩක් අඩුයි. හරිද? මේ overall bit duration එකට වැඩිය spreading code එකේ bit duration එක ගොඩක් අඩුයි, right? So if it is less than the overall bit duration, then I can multiply these two. Multiply it, right? So when you multiply this bit duration by bit 1, this is what you will get. For bit 1 duration, this is what you will get. Okay? So how do you multiply? 1 into 1 is 1. 0 into 1 is 0. Right? 1 into 1 is 1. 1 into 1 is 1. 0 into 1 is 0. 1 into 1, 1. 1. 1. Then 0 into again 0, 0, 0. Right? This is the encoded sequence. Encoded sequence. Or coded sequence. Coded sequence. Right? මේ තියෙන coded sequence. අර code එක අපි spreading code එක apply කරනවා අපේ original data sequence එකට. එතකොට ඒක coded sequence එකක් විදිහට කියනවා. දැන් අපි bit 1 වෙනුවට යවන්න මෙන්න මේ code එක. Right? So instead of bit 1, we send this bit sequence. So when we send this bit sequence instead of bit 1, is it easy to decode or difficult to decode? It is very difficult to decode, right? If somebody is listening to this bit sequence or this transmission, he can't just look at this sequence and think that, okay, they have transmitted bit 1. How can you think like that, right? So you get this sequence. If you tap the signal, you get this sequence. නේද? signal එක tap කළොත් හම්බෙන්නේ මේකනේ. එතකොට යාට හිතන්න පුළුවන් එකපාරටම if we did not know about any spreading code, or even if we knew about spreading code, can we decode this easily without knowing the code? Spreading code එක දන්නේ නැතුව මේක decode කරන්න අමාරුයි. Decode කරන methods තියෙනවා, right? So there are some features. Now for example, decode කරන methods තියෙනවා කියන්නේ මෙහෙමයි. දැන් for example, now this is the pseudorandom bit sequence. Okay, this is completely unpredictable by the eavesdropper. Eavesdropper ට මේක predict කරන්න බෑනේ. හරිද? මේ sequence එක generate කරන්න transmitter එකේ pseudorandom. It is a random sequence. ඒක generate කරලා 1 වලින් වැඩි කරාම බලන්න A sequence එකම තමයි හම්බෙන්නේ as the spreaded signal or coded sequence. Coded sequence එක විදිහට හම්බෙන්නේ අර random bit sequence එකම තමයි. මොකද 1 වලින් multiply කරාම වෙනසක් නැහැනේ. හරිද? 0 වලින් multiply කරාම බලන්න මේකේ අනිත් පැත්ත හම්බෙන්නේ. A sequence එකේ අනිත් පැත්ත. හරිද? ඊළඟට ආයේ 1 වලින් multiply කරාම A sequence එකම තමයි. මේ sequence එකම තමයි. 0 වලින් multiply කරාම අනිත් පැත්ත නෙමෙයි දෙන්නේ කියන්නේ. Right? So when you multiply your if the original signal is 0 and you multiply it by the spreading code, you will get the mirror image of the spreading code as the spreaded code. Right? So now if somebody is listening to this data transmission, if they have listened to enough amount of data transmission, then they can decode it. Okay? යම් කිසි වෙලාවක් මෙයා මේ transmission එකට අහුම්කම් දීගෙන ඉඳියොත් එයාට ඒක decode කරගන්න පුළුවන්. After observing the bit sequence, if it is, you know, if this is coming like this and it is completely I mean flipped, right? The side it is flipped, then again it is coming like this. So he can kind of decode it. He can listen to it, but you have to listen to it for some time, right? You have to listen to the transmission for some time in order to decode it. Okay, but it is better than directly getting the information. නේද? ඒක වෙලාව ගිහිල්ලා decode කරගන්න එක හොඳයි. මොකද ඒක එයාට කෙටි කාලයක් නම් eavesdrop කරන්න පුළුවන් උනේ. එකපාරට මේ signal එක decode කරගන්න අමාරුයි. නමුත් යම් කිසි කාලයක් එයා eavesdrop කරගෙන ඉඳලා ඉන්දියොත් ඒ pattern එක අඳුරගන්න පුළුවන්. නමුත් කෙටි කාලයකින් බෑ. හැබැයි raw data transmit කරොත් කිසිම coding technique එකක් පාවිච්චි නොකර එයාට කෙලින්ම තොරතුරු ටික හම්බ වෙනවා. Right? So he will get the information easily. Okay, so this is the purpose of the frequency hopping spread spectrum as well as direct sequence spread spectrum. Understood? Any questions? So this is the final transmitted signal. Instead of this one, I am now transmitting this one. So can you see the difference between these two? The first one, original signal, and the spreaded signal. It has a huge difference, right? So you can't just look at the spreaded signal and say, all right, they have transmitted 0. Then you can't just look at it and say they have transmitted 1 without knowing the code. If you don't know the code, you can't just look at the information transmitted signal and say what they have transmitted. At the receiver, they know the code. Receiver knows the code. So if the receiver knows the code, a receiver can do some operation in this particular sequence and receiver can decode it. Okay, receiver can decode කරගන්න පුළුවන්. Understood? So spreading techniques, spread spectrum techniques are mostly used to ensure the security of data transmission. Okay, now because of the spreading techniques, we have a different multiple access technique called code division multiple access, CDMA. CDMA කියන multiple access technique එක base වෙලා තියෙන්නේ ඔන්න ඔය spread spectrum technique වලින්. Right? Anyone have any confusion? You didn't understand, I can explain it again. දරු කියන්න. මොනවාද ප්‍රශ්න තියෙන්නේ?
madam.
තේරුණා නැද්ද? ආයි කියන්න ඕනද? Okay, so you can read this further if you want. Right. Then, okay. So now spread spectrum based multiple access. හරිද? Spread spectrum based multiple access technique එකක් තියෙනවා. මම කිව්වේ CDMA, code division multiple access. So code means the spreading code. Okay. Code means the pseudo random spreading code. Okay. Pseudo random bit sequence. That is what the code is. Okay. Right. Now you are clear with the spreading techniques, right? Now based on the spreading techniques, we can define another multiple access system called code division multiple access. Okay, let's read this. Spread spectrum is spreading the bandwidth needed to transmit data. Okay. The desired signal is transmitted over a bandwidth which is much larger. Ne? Our initial bandwidth එක වගේ නෙමෙයි. Now it has been transmitted through a larger bandwidth. It is first developed for military applications. For the main reason is security, like I said. Second one is undetectability. So probability of being detected is less. What is undetectability and security difference? Security means you can't easily, identify your original information. Security means by changing either your frequency, transmission frequency is frequently changed, right? So then you can't easily tap or identify it at once, okay, original information. Again, in the DSSS case, also you can't just look at the transmitted signal and decode your information at once. So that is security. What is undetectability? Undetectability means now our signal is spread in frequency domain. මං කිව්වා එක it looks like noise. ඒක noise වගේ තමයි පේන්නේ. ඔය දැන් original signal එකේ power එකට වැඩිය මේකේ power එක අඩුයි සහ ලොකු frequency range එක spread වෙලා තියෙනවා. එතකොට detect කරන්න අමාරුයි. Right? So you can't easily detect your signal because of minimum probability of being detected. The probability of being detected is minimum. Okay. Yes. Then it is robust against intentional jammers. Okay. So it can resist jamming. Right. So frequency hopped multiple access is one multiple access method. The other one is code division multiple access. Code division multiple access is based on DSSS, direct sequence spread spectrum technique. Now frequency hopping spread spectrum will give frequency hopped multiple access. That is one kind of a multiple access technique. The other one is direct sequence multiple access. Or we much popular word is CDMA. Okay, much popular word is CDMA, right? So these two multiple access techniques are used for users which are, if we are sending our information to multiple users using spread spectrum techniques, then we have to use these two multiple access methods. Spread spectrum techniques වලින් නම් අපි data transmit කරන්නේ. එහෙනම් මේ multiple access methods එක පාවිච්චි කරන්න ඕනේ users ලා ගොඩක් අතර අපේ information බෙදන්න. Right? Right. So frequency hopping multiple access. Okay, we have only a small part. Okay. Frequency hopping multiple access means the carrier frequency of users are varied in a pseudo-random fashion. User ke carrier frequency එක random fashion එකේ වෙනස් වෙනවා. Pseudo-random means it is not extremely random, but it is not extremely deterministic. නේද? Pseudo-random කියන්නේ මොකද? භාගිත random කියන්නේ. ඒ කියන්නේ සම්පූර්ණයෙන්ම random නෑ. හැබැයි සම්පූර්ණයෙන්ම predictable උත් නෑ. Right? It is pseudo-random. It is kind of random. Isn't it kind of random in frequency hopping spread spectrum? It is random. Make a random. Right? When you look at it at once, you can't see any pattern. It is random. But the pattern repeats. If you carefully listen to it for quite some time, you can see that the pattern has been repeated. Okay, that's what we call it as pseudo-random. Okay, here also it's same. Pseudo-random means it's not completely random. Now this is definitely random, right? But it has been repeated again. But you know, when this comes and then bit one comes, you can't just look at it and say, okay, it has repeated. It has been repeated. No, you can't. Just by looking at it, you can't say. But by listening to it for quite some time, then you can figure it out. That's what it says. It says as it is pseudo-random. That means this has been repeated once again after some number of bits. It has been repeated once again, but you can't easily tap into it. You can tap into it, but you can't easily do it. That's what it means. It is not completely random. If it is completely random, then it will be very difficult for the receiver to decode it. අපි data සම්පූර්ණයෙන්ම වෙනස් කරලා යවුවොත් එහෙම random form එකකින් තේරුමක් තියෙන data alter කරනවා. If the receiver doesn't know how to decode it, it's going to be difficult. Okay, there is no use of sending information like that. Your information is destroyed. You can't decode it at the receiver. So eavesdropper can't listen to it, right? That purpose is achieved. But what's the purpose of altering your information, original information, and sending it through the channel? And receiver can't decode it. There's no point. Your information is lost, right? So you can't make it completely random. That's why. That is the reason why. Okay. Then each user is using a narrowband channel at a specific instant of time, right? And the random change of frequency makes the change of using same narrowband channel very low. Now I am not, same user is not using the same channel every time, right? I am using different multiple channels with time, right? I am hopping between multiple channels with time in frequency hopping multiple access, right? Since this is a multiple access technique, it involves multiple users. User 1, user 2, user 3, and so on. These users will be given F1, F2, and so on at one time. Okay? F2, F3. Then after some time, user 1 will receive information through F3. Right? F3, F1, F2, likewise. Then after some time, user 1 will receive information through F2. So it will hop between different frequencies with time, right? That is what is called frequency hopping multiple access. Okay, user 1, user 2, and user 3, they will receive information with different frequencies at different times. Okay, so rate of hopping versus symbol rate. Now this depending on the rate of hopping and the symbol rate or the transmission rate, we can divide this hopping into two categories called the fast frequency hopping and slow frequency hopping. Okay, so if the hopping rate is higher than the symbol rate, that is called fast frequency hopping, right? So that means one bit is transmitted in multiple frequencies. And if the symbol rate is greater than the hopping rate, then we call it as slow frequency hopping. In slow frequency hopping, multiple bits are transmitted in a hopping period. Now here, in this particular figure, multiple bits are transmitted in one period, right? So that means we have used slow frequency hopping. මෙතන පාවිච්චි කරලා තියෙන slow frequency hopping, right? Because multiple bits are transmitted using one period. Now here, 700 kilohertz, 101 is transmitted through 700 kilohertz. Kilohertz 700 දී transmit කරලා තියෙන්නේ 101. So multiple bits are transmitted in one hop period. So this is slow frequency hopping. Okay. So slow frequency hopping. Fast frequency hopping means slow frequency hopping, and here 900 kilohertz is transmitted by 111. 111 is transmitted through 900 kilohertz. Likewise. නේද bits ගොඩක් එකට transmit කරලා තියෙනවා එක frequency එකකින්. නේද? That is slow frequency hopping. Fast frequency hopping means if I transmit bit 1, I transmit bit 1 using 700 kilohertz at one time. Then after some time, I send bit 1 through 900 kilohertz. There are bit 1 මුලින් 700 වලින් transmit කරනවා ඊළඟට 900 වලින්. That is called fast hopping. Fast hopping. Okay? That is fast frequency hopping. That's what it says. Okay? For slow frequency hopping, these are the examples. GSM and Bluetooth. Cdma. This is very popular. Code division multiple access. It is based on FDC code division spread spectrum technique, right? Based on, this is based on CDSS, right? ඔයගොල්ලන්ගේ තව subjects කීයක් ඉතුරු වෙලා තියෙනවද කරන්න? තාම
subject
දෙකක් නේ. මේකත් එක්කද? වගේ ඒවා මේ කියන්නේ වැඩිපුර lectures නෑනේ. එකක් කීයක් වගේද තියෙනවා කරන්න?
එක subject එක නම් තව කොහොමත් lectures දෙකක් විතර තියෙයි මේ එක lecture එකක් නම් අපේ HOD මේ කවුද software HOD දෙකන්න මේ සර්ට කරන්න බැරිුණා අද දෙකක් දවස් දෙක ගන්න.
හරි අපි එතකොට දරුවෝ තව දෙකකින් විතර ඉවර කරන්න පුළුවන්. හරිද? අපි පැය 3 දෙකක් කොහොම හරි දාමු weekend එකේ හරි කමන්නේ දවස් දෙකනේ තව ඕනේ. මේ එහෙම නැතුව මට week days වල පැය 3ක් දාන්න අමාරුයි ඒකයි. හරි. අපි සෙනසුරාදා එමුනොත් මේ සෙනසුරාදා පුළුවන් මේ සෙනසුරාදා පුළුවන් වේද දන්නේ නැහැ. පුළුවන් වුණොත් මම කියන්නම්. හරිද? මේ සෙනසුරාදා දාන්න තිබුණොත් හොඳයි. Right. So we'll do something about it, okay? මේ සතියේම තව දවසක් දෙකක් අහු වුණොත් මම කියන්නම්. week days වල. හරිද?
හරි මඩ. weekday බදාදා අපිට බදාදා උදේ පුළුවන්
බදාදා උදේ ඔයගොල්ලෝ කිව්වේ මට බදාදා පුළුවන් වෙන්නේ දරුවා 8:00ට ඉස්සෙල්ලා තමයි. 8:00ට ඉස්සෙල්ලා 4:00ට පස්සේ. එහෙමයි කරන්නේ.
අපිට බයි දින් හරිය නෑ නේද අපිට හෙට හවස එක.
හෙට නම් මට බැරි වෙයි. හෙට මට බැරි වෙයි.
එහෙනම් සිකුරාදා හරි බලමු.
සිකුරාදා පොඩක් බලන්න සිකුරාදා පුළුවන්ද කියලා. හරිද?
පුළුවන් මැඩම් උදේ වරු.
හරි. සිකුරාදා බලන්න සිකුරාදා 8:00 ඉස්සෙල්ලා මට පුළුවන්. 8:00 ඉස්සෙල්ලා.
පුළුවන්.
හරිද? පොඩක් බලන්නකො නැත්තම් හවස මට කියන්න 4:00 පස්සේ පුළුවන්ද කියලා සිකුරාදා. පුළුවන් නම් හවස ස්ලොට් එක මේ ෆ්‍රී කරගන්න බලන්නකො. 7ටද 4:00 5:00 6:00 හැබැයි 4:00 පස්සේ පැය දෙකක් කරන්න පුළුවන් නේද? නැත්නම් 5ට පටන් ගත්තත් පැය දෙකක් 7 වෙනකම් කරන්න පුළුවන් නේ. අපි චුට්ටක් බලමු එහෙනම් මට සිකුරාදා මන්ට පොඩ මතක් කරන්න. හරිද? එතකොට තව සෙනසුරාදාත් එකක් විතර දාගත්තාම ලේසියි. Okay. Right. TDMA means again we use code division spread spectrum technique, right? So in CDMA, the narrowband message signal is multiplied by a very large bandwidth signal called the spreading signal, right? So this is, I explained this before, right? So we use a spreading signal before modulation, and when you transmit over the air, before transmission over the air, you spread it. right? And that is called the spreading. Right? Then CDMA is also called direct sequence spread spectrum. It is based on DSSS. CDMA based on DSSS. So all users in CDMA use same carrier frequency and transmit simultaneously, but they can use different transmission codes. එක user එක code එක ගානේ පාවිච්චි කරලා අපිට CDMA වලින් multiple access කරන්න පුළුවන්. Right? The same signal is recovered by de-spreading process. At the receiver, there is a de-spreading process, and you can recover the signal back at the receiver, right? Okay, then we have, this is how you, just like FDMA and TDMA, this is how you represent CDMA. CDMA pennane mehema. Now here in the time axis, it is not divided. Frequency axis is also not divided, but the code axis is divided because different users have different codes. Different users have different codes. Different users have different code sequences, right? Different users have different code sequences. This is how you draw it. Now, you know, when you get the slide, please go through these images again and see the difference. එකම පිටුවක මේ තුන ඇඳලා බලන්න මේ තුනේ වෙනස මොකක්ද කියලා. මොකක්ද? The coding axis is divided in this case. In FDMA case, frequency axis is divided, and in TDMA case, time axis is divided. Try to practice to draw this. You know, many of the students they can't draw it properly, right? So they draw something, they do not understand what's happening. They just draw something that when I was marking the papers for the previous batch, I saw that they were confused and they have not drawn it properly. So you have to please practice it, right? So when I ask you to write what CDMA is, you can explain it in few words and you can draw it properly. Okay, then you will get full marks. Again, the same thing is explained here, right? Data signal, how it is spreaded using the spreading code and how you get the output. Okay. Then SDMA. SDMA means space division multiple access. Now use spot beam antennas or directional antennas, right? Spot beam antenna. Now this antenna can transmit in these three directions. Okay? Now I can send information to different users by using space division. I am not, different beam areas can use TDMA, FDMA and CDMA technique. May beam areas FDMA, CDMA techniques පාවිච්චි කරන්න පුළුවන්. And different users are accessed with different antennas, right? Then sectoring. Sectoring ගැන මම කතා කරන්නේ අර cell එකක් sector කරන විදිහ ගැන මම කතා කරා. අන්න ඒ වගේ දෙයක් තමයි මෙතන වෙන්නේ. Sectorized antenna can be thought of as a SDMA. Cell sectoring ගැන මම කතා කරා. That is very important, right? What is cell sectoring? Now when you take a cell like this, now you can you can divide this cell into 3 sectors like this. And this is your base station antenna, and you can transmit your signal only to this half sector, right? This 1/3 of the cell, like this, in 180 degree. That is called cell sectoring. Cell sectoring. So the same concept is used in space division multiple access. Adaptive antennas can be used in the future simultaneously share energy in the direction of many users, right? So now this is the space division multiple access. It is also used along with other multiple access techniques. හරිද? මේකත් අනිත් ඒවාත් එක්ක පාවිච්චි කරන technique එක, right? Okay, now we are done with the multiple access part. Multiple access part එක ඉවරයි. So I think we should mark attendance first and then let's mark attendance first. Then we will do the generations of mobile communication. Okay. Now you also did many of you did presentations on mobile communication generation, right? For your assignment. And also, I have to give you another assignment. I'll send you the assignment. You have to make a report of a maximum of 3 pages. Right? පිටු 3ක් උඩරිම ලියන්න. But don't copy it from the internet. Just prepare a report. I'll give you the topic. Okay. I'll send you the topic maybe today itself. Then you can, within a week, you can prepare the assignment. Okay, so we will have 2 assignments and I'll give you the overall marks based on the, I'll take the average mark from both assignments, right? They came average එක මම ගන්නවා. හරිද? So don't be absent. Don't be absent. So it is a online submission. You don't have to come in person to write the answers. නේද? Online submission එකක් මේක නිසා ඔයගොල්ලෝ අනිවාර්යෙන් හැමෝම submit කරන්න. Then I can take the average. Please tell everyone, those who are absent also today, to be present or to send your assignments within the deadline. Okay, tell everybody. Right. So generations of mobile communication, different generations. Now we already know these generations span from generation 0 to generation 5. Right now we are experiencing 5G, right? So it is not been implemented, but we are experiencing 5G right now. Okay, so today I'll do up to 4G, how it how the technologies are used up to 4G, and maybe if time permits, I'll explain a little bit about 4G more and also 5G later on. Okay, in the next lecture, right? So now the starting of this wireless communication or mobile communication. What is the starting point? Who found this? The Alexander Graham Bell, right? He was the first person who found the telephone. He's the first person who, told that we can communicate between 2 remote locations without, going to the other place. We can communicate between 2 remote locations, right? So that is by using the telephone. Now it was first introduced by the Alexander Graham Bell in 1880, right? First telephone was introduced by the Alexander Graham Bell in 1880. Then, the mobile, now initially the telephone is not mobile, right? The phone is not mobile. It is a fixed phone, right? The first introduced telephone is fixed. But how it was made mobile, it was mounted on the car, right? Then the first car-mounted radio telephone was introduced in 1921. Now it was, the mobile kind of technology for this fixed telephone was introduced in 1921, right? Okay, then we have the first commercial mobile radio telephone that was developed by Bell and AT&T laboratories in United States, right? And it used half duplex technique. So we always give the example of half duplex. Half duplex an example like the walkie-talkie and all these things, right? So it is using the push-to-talk technology, right? So walkie-talkie is also based on the push-to-talk technology, right? So you communicate with the in one direction from transmitter to receiver at one time, and from receiver to transmitter at another time. So you can't communicate between 2 ends simultaneously, right? So it was first introduced in 1946, which is not so far away. Okay, it is, you know, the mobile communication generations developed really fast, right? So mobile communication that we are experiencing today, the development didn't take much time. Like the first commercial mobile radio telephone was introduced in 1946, which is not that, I mean, much far away. It doesn't have so much, you know, history to it. It developed rapidly. The reason is that with the exponential growth of electronics, right? So IC technologies. Now, with the with the introduction of transistors and with the introduction of with the development of different IC manufacturing technologies, right? So the sizes of all these, vast equipments or radio transmitters, receivers, they decreased with time, and it happened rapidly, right? Due to the advancement of technological aspects in electronics, right? So because of that, the transmitter and the receiver circuitries, sizes of these circuitries reduced with time exponentially, and it didn't take much time. It only took a let's say a century to develop this to a larger extent, right? Not even a century, right? Within a 50, 60 years, it has, come such a long way, right? Then in 1973, the first handheld cellular telephone was introduced by Motorola, right? Now, Motorola introduced the first handheld cellular telephone in 1973, which is quite, I mean, closer, right? Compared to other technologies, it didn't take ages, right? Didn't take ages. Then the first cellular net or net was introduced in Bahrain in 1978. The network, the first cellular network was implemented in Bahrain in 1978, right? So you can see in this figure, a particular figure, that these are the kinds of radio telephones which we call as mobile phones that were used back in the day, 1990s, right? 1980s, 70s, and 90s. These were the kinds of telephones or radio telephones or mobile phones that had this kind of a huge antenna and a kind of a box type structure to it, right? Why it is quite big? Because the transmitter and the receiver circuitries are quite big back in the day, right? Then this is the kind of technology used, right? So what is the introduction of the history behind introduction of the cellular networks? Now, as you all know, cellular networks are based on dividing a certain geographical area into different parts called cells. The hexagonal parts called cells, right? So when you read the first point, radio network distributed over land areas called cells, right? So we divide our overall geographical area into cells, right? Each cell is served by at least one fixed location transceiver known as cell site or the base station. Now each cell is served by a base station, which is located in the middle of the cell. So it is allocated with a set of frequencies, and it can communicate with the users who are located within that cellular area. නේද? ඒ cell එක ඇතුළේ තියෙන users ලාට services provide කරනවා ඒ base station එක. cell එක ඇතුළේ තියෙන base station එක. So we have already discussed about the cellular network implementation, right? We have also discussed about cellular network implementation. We kind of designed different, frequency allocations to different cell sites. Neither frequency allocation, we did about frequency reuse concept. We also solved a lot of questions, right? So what I'm trying to say is now, I didn't discuss about the GSM network architecture. So once we discuss about the GSM network architecture, then you will get a pretty good idea of how this overall cellular network is functioning. The overall cellular network is from the function idea GSM network architecture, right? So then when joined together, these cells provide radio coverage over a wide geographical area. So the overall cell coverage එක මුළු area එකටම දෙන්න පුළුවන් using different strategies called frequency reuse concept. The frequency reuse concept වගේ strategy පාවිච්චි කරලා limited spectrum එකකින් ලොකු users ලා ගන්නකට services දෙන්න පුළුවන් cellular network එකක් හරහා, right? So that is the main purpose of implementing a cellular network. Okay. So this enables large number of portable transceivers. So our mobile phone is a transceiver, right? Transceiver, the word transceiver means you can transmit and receive within the same circuitry, right? So you do not need a separate mobile phone to transmit, right? If our mobile phone is only a transmitter, then we need a separate phone to transmit and a separate phone to receive, right? So that is not the case. Our mobile phones are transceivers. Transceivers means we can transmit and receive at the same time, right? So we can enable large number of transceivers. We can provide services to large number of transceivers at the same time. එකම වෙලාවේ, I mean, ගොඩාක් services users ලා ගොඩකට services දෙන්න පුළුවන්, serve කරන්න පුළුවන් cellular network එක හරහා, right? And to communicate, this is the most important one here. Now we can accommodate large number of users as well as we can make them communicate with each other and with fixed transceivers and telephones. So that is the important one. That means you can communicate with another mobile user as well as with a fixed telephone user. Okay? අන්න ඒකයි වැදගත්. දැන් cellular network එකක් තමයි users ලා ගොඩකට service එක දෙන්න පුළුවන්. Using a limited spectrum, we can provide services to large number of users. That is the first advantage. And the second advantage is we can communicate between different mobile users as well as with different fixed telephone users. Fixed telephone network එකත් communicate කරන්න පුළුවන්. Mobile users ලත් එකත් communicate කරන්න පුළුවන්. That is the second feature, right? Anywhere in the network via base station. Even if some of the transceivers are moving through more than one cell during transmission, right? Even if some of the transceivers are moving. හරිද? එතකොට දැන් මම තව mobile එකක් එක්ක communicate කරන ගමන් ඒ mobile එක that mobile can be moving somewhere, right? From cell to cell, but still my call is not dropped, right? So I can also be moving at the same time. My call is not dropped, right? So using this particular cellular network technology, we can maintain a proper call between two ends, between two mobile users as well as between mobile users and land phone users at the same time without any service interruption, using strategies like frequency reuse and handoff. අර mobile communication කියන එක enable වෙන්නේ handoff කියන එක. يعني ගොඩක් long distance mobile communication is enabled through handoff, right? So if we are within the cell area and we are moving inside the cell area, it's fine. But what if we are moving outside the cell area, right? So we should have a different strategy that is called handoff, right? So we have different techniques of handoff. I explained you already, right? So just remember, now with the implementation of cellular concept, this mobile communication thing, it expanded vastly, right? So it developed so fast because of the introduction of cellular networks, right? Now cellular networks was first introduced in the GSM by the GSM, Global System for Mobile Communication, right? GSM standard. First cellular network concept was introduced by the GSM standard in 2G, right? So we'll come to it. Then the cellular concept, the motivation. What is the reason for introducing the cellular concept, right? Large coverage with single high-powered transmitter. That means our base station. This is about the base station. Now, in previous mobile radio systems, we had a single base station to cover a very large area. Like for example, broadcast antenna. TV broadcasting වල එහෙම තියෙන්නේ. එහෙනම් TV broadcasting වල එක area එක ලොකු කන්දක් මත තමයි broadcasting tower එක තියෙන්නේ, right? And from that tower, if possible, they can provide signal to the whole country, right? එක tower එක broadcast broadcasting tower, right? So in early mobile radio systems, they used large antennas, huge the height is high, antenna height is high, and high power antennas to cover a large area, right? So in that case, they did not use the frequency reuse concept, right? So they did not use the frequency reuse concept. Frequency reuse concept එක පාවිච්චි කරේ නැහැ. Very high antenna with large, transmission power. We can accommodate multiple users, but again, our spectrum is very limited. So how do we address? Now, if the number of users are increasing, we have to provide service to millions of users. But just using one antenna, can we do it? No, because we have only few number of frequencies to share with millions of users. So how can we do that? Now, to solve that problem, we use the frequency reuse concept and cellular concept. Cellular concept එකෙන් තමයි මේ ප්‍රශ්නය විසඳුනේ. ප්‍රශ්නය මොකද්ද? users ලා ගන්න වැඩි වෙනවා එන්නෙන්නම. නමුත් අපේ frequency අපි ළඟ තියෙන බෑන්ඩ් එකේ තියෙන frequency radio frequency band එක වෙනස් වෙන්නේ නැහැ නේ. හරිද? radio frequency band එකේ තියෙන limited frequency spectrum එක. හරිද? ඒක හැමමයි. හරිද? එහෙම වුණාම මේකෙන් services දෙන්න පුළුවන් users ලා ගන්න අඩුයි. හරිද? But with the increasing of number of mobile users, we can't accommodate all users at once. එකම users ලා ඔක්කොටම එකපාර එක antenna එකකින් services දෙන්න බෑ. Why? Because we don't have many frequencies available, right? So we can't use this concept anymore. So we have to opt for some other technology, some other concept, which is the cellular concept. Cellular concept gave the solution for this problem. මේ ප්‍රශ්නයට solution එක දුන්නේ cellular concept එකෙන්. And especially the frequency reuse concept. Frequency reuse කියන concept එකෙන් තමයි මේ ප්‍රශ්නෙට විසඳුම දුන්නේ. Now, frequency reuse is the main idea behind cellular implementation. Cellular implementation එක ඇතුලේ තියෙන හොඳම idea එක තමයි frequency reuse කියන්නේ, right? So you can go back to your previous lectures and have the refresh your mind about what is frequency reuse, how we allocate the frequencies, right? How frequencies are divided between different cells, different base stations, and how clusters are formed and how clusters are repeated, and how the capacity can be increased. I have discussed everything before, right? And then the last point, since finite spectrum allocation, we need high capacity, like the same thing I said, finite spectrum allocation. That means our spectrum is limited. Our spectrum is limited, right? And then we have to accommodate for large number of users. So from day by day, the number of users are being added to the system. So we have to provide services to large number of users, but just with finite frequency spectrum, right? Then and wide coverage. So all these things, to address all these issues, the cellular concept gave a solution, right? How that solution came? Especially using this frequency reuse. Okay. Now we have these generations available up to date. Right? We have generation 0, 1, 2, 2.5, 2.75, 3, 4, 5. Okay. Then 0. First, 0 generation. 0 generation was introduced in 1945, right? Then not officially categorized as mobile phones, since it did not support the automatic change of channel frequency during calls. So there is no handover feature in generation 0. 0 generation එකේ handover feature එකක් නැහැ. හරිද? එතකොට ඒක mobile ම කියලා අපිට කියන්න බෑ, right? Now there is no handing over of the call in progress if you are moving from your service area to another service area, right? So which allows the user to move from one cell to the another cell, a feature called handover, right? It was not introduced in first generation, 0 generation mobile communication, right? Technologies used were these technologies: push to talk, like walkie-talkies, right? Then mobile telephone system, MTS, is another technology that was used in the 0th generation. 0th generation ke push to talk manual, MTS, then IMTS, right, and AMTS. So these are, kind of popular standards. Improved mobile phone service. You can, search the internet and find the differences between these technologies, right? So, but generation 0, what you have to remember is there is no handoff technique, right? And also they use these kinds of technologies, and also these are the other features. Right. So in zeroth generation, these are the technologies that were used. Okay. So those are the things you should remember. Then first generation. First generation used analog communication, analog modulation technique for signal transfer, and mostly telephony only. හරිද? Data කතාවක් මෙතන නැහැ. Right? So only voice communication. That means only voice. Mostly telephony means only voice. First generation was dedicated only for voice transmission, right? Virtually no data capability other than special devices analog modem. So there is no data capability. Voice transmission was enabled. Voice transmission only purpose is for voice transmission, right? So in 1G network, voice calls were simply modulated to higher frequencies, typically up to 150 megahertz. And now, no international roaming. It was not possible. Incompatible systems. You are not compatible with your mobile system and the fixed telephone system. Neither fixed telephone system එකයි mobile system අතර compatibility එකක් නැහැ. Mobile system එකෙත් එක technologies අතර compatibility එකක් නැහැ. So systems are incompatible, right? Little capacity. You cannot accommodate so many users. You cannot accommodate for masses of subscribers. Subscribers na million ගානකට accommodate කරන්න බෑ. සල්ලි තියෙන මිනිස්සු විතරයි මේ වගේ first generation mobile technology එක පාවිච්චි කරන්න පුළුවන්. So not many users could use it. Okay, this generation does not exist anymore. It is all very obsolete. Obsolete means very old. It does not exist anymore, right? Then this is the technology used in the first generation mobile communication. So in questions, these kinds of things may be asked. So what is the technology behind first generation mobile? AMPS is the technology, right? AMPS, Advanced Mobile Telephone System. AMPS කියන මොකද්ද? Advanced Mobile Telephone System. So that is the technology used in the first generation mobile communication system. Okay. Total of 40 megahertz of spectrum was allocated from 800 megahertz band by the FCC. Now this AMPS was a USA based, so it was used in states, right? United States, by the Federal Communication Commission. This is the Telecommunication Regulatory Commission in United States, right? For AMPS. It was first developed in Chicago with a service area of 2,100 square miles, right? So it could only provide services up to 2,100 square miles, right? So AMPS can පොඩ්ඩක් මතක තියාගන්න. Advanced Mobile Telephone System, right? Then it offered how many channels? 832 channels with a data rate of 10 kbps. So it could provide some data communication with a data rate of 10 kbps, which is very less. So when you compare the data rates that we have today, this is a very less data rate. Although omnidirectional antennas were used. Omnidirectional means your transmission is at 360 degrees. නේද? හැම direction එකටම හැම අංශක 360ටම transmit කරනවා. Antennas were used in the earlier MPS implementation. It was realized that using directional antennas would yield better cell reuse. Now, of course, you can increase your cell reuse by using directional antennas. Can anybody tell me why? Cell reuse එක වැඩි කරනවා directional antennas පාවිච්චි කරලා. The reason is the chances for interference is less. If you use directional antennas, the chances for interference is less, right? So then you reuse your frequencies again and again, right? So the omnidirectional antenna එකකින් transmit කරනවා වෙන්නේ directional antennas පාවිච්චි කරාම interference සිද්ධ වෙන සම්භාවිතාවය අඩු වෙනවා. ඒතර ඔයගොල්ලන් ළඟ තියෙන limited frequencies ආයෙ නැවත පාවිච්චි කරන්න පුළුවන්. Okay. Now in AMPS 7-cell reuse pattern was adopted. හරිද? AMPS වල 7-cell reuse pattern එක පාවිච්චි කරා. In Europe, now Europe did not use AMPS. They used a technology called TACS, Total Access Communication System. TACS, okay? So in United States, they use AMPS. In Europe, they use TACS, okay? TACS. Now AMPS and TACS are the two technologies that are associated with first generation mobile. හරිද? ඒතර 1G වල තියෙන technologies දෙක තමයි AMPS and TACS කියන්නේ. මතක තියාගන්න. Right? And they use frequency modulation. It is a analog modulation technique. I explained you what is the difference between analog modulation and digital modulation. Right? So first generation mobile communication is based on analog technique, right? Which is frequency modulation. Okay. Frequency modulation was used for radio transmission in first generation mobile communication. Understood? See, the data rates are very less, 8 kbps, 10 kbps. Okay. Then we have second generation, 2G. 2G voice communication was digitally encrypted. Now, this is the first, second generation tama mulinna digital transmission එකක් එහෙනම් digital modulation techniques introduce kare data communication, voice communication, right? It enhanced data services. Now, with second generation, we had more data services than in first generation, right? So data capability includes internet access and picture sharing. So using 2G technology, we could have internet access and picture sharing in the mobile device, right? So data services were enabled. Then introduced SMS, right? Then increased capacity. Capacity is increased. What is capacity again? Capacity කියන්නේ මොකක්ද? Subscribers ලගාන්නේ. The number of subscribers or number of mobile devices that you can provide your services to, right? So the capacity was increased, security is high, more compatible, right? And can use TDMA or FDMA for increasing capacity. So these are multiple access techniques. Why do we need multiple access techniques? To accommodate multiple users, to share the same medium, right? So we used TDMA or Cdma multiple access techniques for to increase capacity furthermore, even more, right? Now, this second generation used GSM, right? Global System for Mobile Communication. That is the standard used in second generation system. Okay. A new design was introduced into the mobile switching center of second generation system. So base station controllers were introduced and mobile switching center was, base station BSCs were introduced in second generation. Second generation introduced the base station controller, right? In addition to enhancements in MSC design, now the BSC will help the MSC. BSC වලින් එකතු වෙන ටිකනේ MSC එකට connect කරන්නේ, right? So MSC is the mobile switching center, right? So BSCs are spread throughout the area, so they will regulate everything that is happening with that particular cell area, and it will be connected to the MSC. It will lighten the load of MSC. MSC වල තියෙන බර එනතර responsibility එක අඩු කරා BSC introduce කරා, base station controller. නේද? base station controller කියන්නේ cell area එකක් ඇතුලේ තියෙන අර transmission tower එක. That is the base station controller or base transceiver station. We call it BTS also. Right? ඊළඟට here, in addition to enhancement in MSC design, now this handoff technique was introduced in second generation, mobile assisted handoff. So I discussed about what is mobile assisted handoff before. So you can go back to the lecture and revise what is mobile assisted handoff, right? So it was introduced in second generation mobile communication system. Then compared to the first generation system, 2G systems used multiple access technologies. These are the multiple access technologies used in 2G. TDMA, Cdma, right? For time division, multiple access, code division, multiple access. Then 2G is based on this standard, GSM. So always remember the long form of GSM, Global System for Mobile Communication. GSM. Okay, long form of GSM is Global System for Mobile Communication. It uses time division multiple access to support multiple users. Okay, so both of these multiple access technologies were used in 2G, right? Then 2.5G. So we are moving from 2G to 3G. 2G to 3G right? So when you move from 2G to 3G, 2G to 3G, there are two intermediate steps, 2.5G and 2.75G. These are the, these are the transitional states from moving from 2G to 3G. 2G and 3G to transitional stages 2.5G and 2.75G. Okay. So 2.5G means the move into 2.5G world began with Gprs. How does the 2.5G වලට එන්නේ Gprs කියන technology එකෙන්. Or just you have to remember the long form of Gprs, General Packet Radio Service. Okay, Gprs is the radio technology for GSM network. Now, initially in 2G network, they only used circuit switching, right? So packet switching was introduced in Gprs in 2.5G. And the 2.5G වල තමයි circuit switch network with a packet switching introduced, right? So shorter setup time for ISP connections, so much speedy connections, the possibility to charge by amount of data. Now, this is another important thing, the possibility to charge by amount of data rather than connection time. Either connection time එකෙන් නෙමෙයි charge කරන්නේ, data කොච්චර consume කරාද කියන එකෙන්. හරිද? නැත්තම් connection එකක් අපිටම internet connect වෙන්න ඕන කියලා connection duration එකෙන් නෙමෙයි charge කරන්නේ, data consume කරපු ප්‍රමාණය. data මගේ මෙච්චර ගියා නම් මෙච්චරයි මම charge කරන්නේ, right? So not the duration. It does not depend on the duration of connection, right? So I can be connected to the internet for 1 minute. If I download a huge file, right, which is of about, megabits, it will consume megabits of gigabits of data. If I download a huge file and I have just connected to the internet for 1 minute, right? So, and I am connecting to the internet for 10 minutes, but I am just using small amount of data. So duration is not a good parameter to charge, right? When you do billing in a communication system, when you do billing, the bill කරනකොට duration එක නෙමෙයි වැදගත්. කොච්චර ප්‍රමාණයක් consume කරාද? කොච්චර bandwidth එකක් consume කරාද? Right? That is the most important thing, right? So this concept of charging or billing, this is charge කරනවා කියන්නේ bill කරනවා, right? The service company, the service provider will bill, right? Billing is done based on the amount of data, not the time, right? Now it was enabled by packet switching, GPRS. Packet switching is a technique whereby the information to be sent is broken into packets. So I don't have to explain you what is packet switching, right? You know that.
Hello. Hello.
Oh, මං කියන එක ඇහෙනවද?
I don't.
හරි. Right. So, okay, can you hear me now?
Yes, madam.
Okay. Right. So, now if you can't hear me, just let me know, okay? Right. So packet switching is a technique. Now your information is broken into packets, right? And then it is routed through the network, right? Based on the destination address, different addressing technique, your packet is routed through the network. You know about packet switching, right? So packet switching is the technology that is used by General Packet Radio Service or GPRS. Okay. Then 2.75G. What is 2.75G? Now the next generation of now heading towards 3G. 3G වල පැත්තට යනකොට ඊළඟට හම්බෙන stepping stone එක තමයි 2.75G, right? Now it introduced another technology called Edge. හරිද? Edge කියන technology එක introduce කරා, that is called Enhanced Data Rate for GSM Evolution. Edge. Please remember the long forms of these technologies. Gprs, General Packet Radio System, right? Edge, Enhanced Data Rate for GSM Evolution. Okay. Now it will accommodate multimedia environments. It's 2.75G වලින් multimedia environments, multimedia services වලට accommodate කරන්න පුළුවන් edge වලින්, right? So 2.75G was the name given to the evolution of edge or enhanced GPRS, right? That is also known as enhanced GPRS. Edge will allow GSM operators to use existing GSM radio bands to offer wireless multimedia IP-based services. හරිද? මේ wireless multimedia IP-based services enable කරේ Edge වලින් 2.75G, right? So you know, you may be asked, right, what is 2G, what is 2.75G, what are the new technologies introduced in 2.5G. So you know, remember the key points. Okay, remember the key points. And applications at theoretical maximum speeds of 384 kbps. Now the access speeds are 384 kbps still in kbps. kbps වලින් තමයි communicate करे, but it allows the use of multimedia services, right? Multimedia services were enabled in 2.75G. Any questions? So actually I'm a little bit doing it in a much higher speed because you know these are facts. There's nothing that you have to understand. You have to go through these slides and you will understand what's written in there, right? So I'm just giving you the key points of each technology. You know, you can search the internet and find more information. 2.75G වල වැදගත්ම දේ තමයි multimedia services, IP-based services introduced services, right? So using Edge, right? So those are the things you should remember. Then implementing Edge will be relatively painless. Implementing Edge is easy because you can use the same network infrastructure as GSM network infrastructure එකම පාවිච්චි කරලා Edge implement කරන්න පුළුවන්, right? So you do not have to replace instruments. So you replace the equipment in the existing network. Network එකේ equipments replace කරන්න නැතුව Edge technology එක පාවිච්චි කරන්න පුළුවන්, right? So it is easy. Then we have the third generation, right? So in first generation, in zeroth generation, then first generation we use analog technologies to communicate, right? And what are the two technologies used in first generation? AMPS and TAG, right? Go through it and identify the different features. Then in second generation, we use the cellular concept. We use the GSM network architecture, right? Then in 2.5G, we used Gprs technology. And 2.75G, we used Edge, right? And in 3G වල මොකද කරන්නේ? 3G mobile telecommunication is a generation of standards for mobile phones and mobile telecommunication services, fulfilling the international mobile telecommunications 2000. So the 3G introduced in 2000, right? In the year of 2000, the 3G was introduced. Specifications by ITU, International Telecommunication Union, which is the International Telecommunication Regulatory Body. International Telecom Union ki tama make a develop kare, right? Application services include now using 3G, we are able to take video calls, mobile TV is possible, right? Voice telephone is possible, mobile internet access, all these, high-end data consuming services are possible with 3G. Okay? So voice is circuit switched, data is packet switched. Then third generation offers multimedia communication capabilities at much higher data rates. Okay, with improved spectrum efficiency. Edge standard is the development of GSM towards 3G. Then GSM can 2G, 2G සිට 3G දක්වා යන stepping stone එක තමයි edge, which belongs to 2.75G. 2.75G. හරිද? මතක තියාගන්න. edge තමයි transitional state එක. 3G towards යන transition එකේ evolution එකේ edge තමයි middle stage එක, right? Then digital system with multimedia services including video phone. Just give me a second. Digital system with multimedia services, including video phone, are now the data rates are up to in Mbps, right? Data rates are in Mbps. Up to 3G, data rates are in Kbps. Kbps are in the transmit now we have in Mbps, right? Web connections up to 2 Mbps. Internet, now all these three things are possible in 3G. Right? Internet surfing is possible. Mobile communication for voice communication is possible. Then media, multimedia services are possible. So all these three in one is enabled in 3G, right? Then the standard based on GSM is called UMTS. Now 3G is implemented in the GSM network itself, and we use this name UMTS to implement 3G. 3G implement standard එක තමයි UMTS කියන්නේ, right? Now please remember this name, Universal Mobile Telecommunication System. What the UMTS කියන්නේ මොකද්ද? Universal Mobile Telecommunication System. It is a third 3G mobile cellular technology for network based on GSM standard. එතකොට GSM standard එකෙන් 3G network access, 3G network, 3G implementation එක කරන්නේ මෙන්න මේක Universal Mobile Telecommunication System, UMTS. Okay, now you might have heard this word. Now previous technologies වල පස්සේ ඔයගොල්ලෝ අහලා නැති වුණාට මේවා අහලා තියෙන්න පුළුවන්, right? Then 3G use completely different radio frequencies from 2G, right? So it required different equipment. Now the only problem is now when you upgrade from 2G to 3G, it required different equipment, which is the downside, to achieve high data rates. Also, the enormous cost of additional spectrum licensing fees delayed the introduction of 3G in many countries, right? So third world countries like us, we got 3G technology later, much later, because of the spectrum licensing fees, right? So you have to buy spectrum, buy the radio spectrum, right? So when you buy the radio spectrum, it is not easy. It is very costly, right? So for third world countries, the 3G introduction was delayed because of this. Okay. Then 3G data transfer rates were 384 to up to 2 Mbps. So it allows for previously unavailable services like video calls. Now these are the new services that are introduced in 3G technology, right? video calls, video conferencing, online conference calls, mobile TV, online gaming, and so on. Right? These were enabled, these multimedia services, these data-hungry services or data-consuming services were introduced in 3G. Right? But the downside is you need to, upgrade your network to implement 3G. Sorry? Understood? Any questions up to now? 3G, 2G, 2.7, 5G? Can pressure I'll give a small introduction about 4G. 4G will for the introduction then next week, next day lecture, I'll introduce some other aspects of 4G and also 5G. Like the 5G can contact Kiana. What is it? So 4G, a 4G system will be able to provide a comprehensive IP solution. Now it is an all IP kind of based mobile network, right? So this is the motto of 4G, anytime, anywhere. Anytime, anywhere, right? So voice, data and streamed multimedia can be given to users on anytime, anywhere basis and at higher data rates, right? So now the evolution of generations from now on, they're more focused on the data rates, right, than previous generations. Now 4G mobile phones are all set to provide data rates up to 100 Mbps to 1 Gbps, which is quite high when you compare it with the 2G technology. 2G පැත්තෙන් ගත්තාම kbps වලින් transmit කරේ, but now we are transmitting in Gbps data rate in 4G, right? Then digital system or voice over IP, VoIP technology. Digital system with it is the system is completely digital, and we use voice over IP. Now we send voice also not using circuit switching. Unlike in 3G, 3G will circuit switching voice packet switching data, right? In 4G we send voice also through IP network, right? Via packets. Voice is packets transmit, right, in 4G. Then that is the services are integrated into all IP networks. The NGN next generation network can, right, where all IP network is enabled. Right? Everything is IP based now. Everything is in third layer of the OSI model. OSI model like a third layer implemented, right? So it is an all IP network. All the services are integrated. Voice services, data services, everything is integrated to the all IP network in 4G, right? Then one of the main ways in which 4G differed technologically from 3G was its elimination of circuit switching. Circuit switching was eliminated the circuit switching and all IP was introduced. This is the important aspect of 4G compared to 3G. 3G වලින් 4G වෙනස් වෙන circuit switching අයින් කරලා. Right? So we needed circuit switching for voice communication, right? So but we eliminated circuit switching and we used packet switching for voice communication also, right? Voice over IP technology. Then 4G ushered in a treatment of voice calls just like any other type of streaming, audio media, utilizing packet switching over internet, right? So this is how voice over IP was enabled. So I can, explain you a bit more about voice over IP and LTE technologies in 4G LTE, VoIP, right? And other latest technologies and also 5G, new radio. Those I'll explain you in the next lecture. Okay. If you have any questions up to now, any clarifications, because I did the lecture a little bit, speedily today. If you have any clarifications regarding anything I taught today, you can ask me. I can explain again. මොනහරි ප්‍රශ්න තියෙනවා doubts තියෙනවා අහන්න. මට ආයි explain කරන්න පුළුවන්. Right? So anybody who joined now, also tell me, I can mark the attendance. Right? Right. මොනහරි ප්‍රශ්න තියෙනවා අහන්න පුළුවන්. අදට මෙච්චරයි. අපි ඊළඟ දවසේ මේ පටන් ගමු because GSM network architecture is very important. It is not completely replaced, right? GSM architecture completely replaced කරලා නැහැ. දැන් තාම අපි 5G අපි ලංකාවේ තාම ඉම්ප්ලිමන්ට් වෙලා නැහැ. 4G වල 4G ඉම්ප්ලිමන්ට් කරාට GSM network එක එහෙමම තියෙනවා. හරිද? GSM network is the basis for everything. Right? So we have to study what is GSM, how the GSM network is implemented, what is the architecture, what is done by different components, right? And there are a few things you should remember in GSM network architecture. So we'll dedicate one lecture for GSM and then another lecture for Bluetooth, Wi-Fi, and other wireless communication technologies. Not just mobile communication, wireless communication it is not just confined to mobile communication, but we have many other wireless, right? Bluetooth. So those are the most common. So I'll introduce you one by one about each different technology. And I can also provide you with extra reading material and go through all these. And I think, okay. Maybe there are some students who are not in networking students. Anyway. Yes, we have only 2 assignments. We have a total of 2 assignments, and I will take the average as the final mark for the assignment. Assignments වලට final mark එක විදිහට දෙකේම average එක ගන්නවා. Now everybody has done with presentations, right? Anybody who is left with presentations, you can do it. Presentations කරේ නැති කවුරු හරි ඉන්නවා නම් ඒව කරන්න පුළුවන්. And please, since this is online submission and you don't have to come and do the quizzes කරන්න physically එන්නේ නැති නිසා ඔයගලන්ට මේක ලේසි. සතියක් දෙකක් අරගෙන මම දැන් අද දැම්මොත් assignment එක මම deadline එකක් දාන්නම්. ඒ වෙද්දී ඔයගොල්ලෝ report එකක් submit කරන්න just 3 pages is enough. Okay? You can submit a report and please don't copy and paste from the internet. I can suddenly I can recognize if you have copied it. And don't use the same report and copy and paste and send me the multiple people will give me the same report, right? So I know that. Don't do it, that will reduce your marks. But you have done your presentations really well, so you have good marks for presentation. But don't take your reports with less importance, because report mark will also be added and the average will be taken as the final mark. Reports marks with presentation marks with decommission. So if you have any objections or any suggestions for that, you can tell me. මොනවා හරි ප්‍රශ්න තියෙනවා නම් ඒ සම්බන්ධයෙන් මට කියන්න. මම ඒ විදිහට adjustments කරන්න. But I am conducting 2 assignments. මට මෙහෙමත් කරන්න පුළුවන්. Assignments දෙකෙන් හොඳම එකේ ලකුණු අරගෙන ගන්නත් පුළුවන්. But it will be a bit unfair, right? So I decided to take the no. I'm not reducing marks for grammar. This is not an English class. So don't worry about the grammar. No. Don't worry about the grammar. There is no way that I'm reducing marks for grammar. So whatever that is, you write the way you write in English, just write it in your own words. That's the most important thing, right? I don't need perfect grammar, okay? I don't expect that. Even I can't write perfect grammar. So I don't expect it. When I read your reports, then I should know that you have written it genuinely. You have done your presentations genuinely, and I highly appreciate that, okay? So, and also writing a report means I have to tell you a few things about writing a report. Just a few tips, okay? When you write a proper report, this is how you write it, okay? Now in the first page, report එකක් ලියනකොට ලියන විදිහ හරියට දැනගන්න. This is the cover page. Then your borders, if you write it in Microsoft Word, your borders should be of 2.5 centimeters. Centimeter 2.5 වෙන්න borders කියන්නේ, right? 2.5 centimeters. Then you can put your university logo here. University of Vocational Technology logo here, right? Then you can write your, assignment to, right, your module name, wireless communication, and the report name. So if I ask you to write about something, just write it. What is the topic, right? Assignment to wireless communication topic. And then your name submitted by your name and registration number, right? So this should be included in the front page, cover page. Okay. And then in the right, when you write the report, again, your borders should be 2.5 centimeters, right? 2.5 centimeters. And your font is Times New Roman. I don't think that I'm, telling you to do so many things, but this is the standard of writing a report. Usual, standard. A university student should know this, Times New Roman. Times New Roman. So use this font, right? And the font size is 12. To write the report, you can use the font size 12, right? And for the topic, you can use the font size 14. Okay, for the topics, you can either use 12 or 14, right? And, there are a lot of other things like you can, topic-wise, when you name the topics, you can put number 1 and 1.1, subtopics 1.1, likewise. It doesn't matter. You can, you don't have to do that strictly. But follow these, okay? It will be, really good if everybody follows the same format. And what else? Right. This is the most important thing. When you finish writing your report, last page, you have to add the reference. This is very important. Okay. You should never write anything. I mean, until and unless that you are doing any original research work. Right? The original research work, අපිම හොයාගත්ත දෙයක් ලියනවා නම් විතරක් references නොදැම්මට කමක් නැහැ. If it is our concept, you don't have to write references. But we are referring from someone else's work, right? So someone else's finding, someone else's website, or someone else's anything. So you have to include where you got your information from. Okay, references 1, 2, likewise. Now, when you add references, there are a lot of things. I can talk for days about referencing, but no. References, if you refer to a website, you can add the link. Okay. Now, Wikipedia is not a good reference, usually. Wikipedia is not a good reference. But it's okay if you refer to Wikipedia, it's fine, right? But good references are books, research articles, or any other articles that are issued by the companies, like, for example, technical document, white papers, over here good references, right? So, but you can refer to websites also, blogs also, right? And other information sites. It's fine. You can also refer to Wikipedia, but you have to add your references here. And you can add your references and you can cite them inside the report. Report එක cite කරන්න ඕනේ. දැන් අපිට ඔයා මෙහෙම වාක්‍යයක් ලියුවා කියලා මොකකින් හරි වාගේ. Right? You write a sentence by finding something from somewhere. මොකක් හරි තොරතුරක් ලියුවා. හැම දෙයකටම reference දාන්න කියලා නෑ. I'm not asking you to write references to everything you write. You can share your own words, own thoughts when you understand the concept, and you can write it in your own words. You don't have to add the reference for that. Okay. What I'm telling is, let's say your data rate for GSM is 2 Mbps. For whatever it is that is 2 Mbps. So from where did you get the data? That is what you have to write. So if you have got it from reference 1, just write it as 1. That is for your own good. I'm telling you. I mean, I'm not strictly following when I'm marking these, but this is how you write a proper report. These are the things that should be included in the report. Okay, in the cover page, then in the content pages also. But don't write more than 3 pages. Okay, excluding the cover page and the reference. references වලට වෙනම පිටුවක් ඕනේ නැහැ. අන්තිම පිටුවේම අගම දැම්මහම හරි. Yeah, that's what I told you. Without front page, right? Without front page, 3 pages. Okay, 3 pages. In the last page, you can add references in the last part. Harinam references වලට වෙනම පිටුවක් දාන්න ඕනේ. The correct way is you have to add a separate page for references, but it's okay if you add your references in the last part of the last page. Okay, it's fine. Don't add too many references, just a maximum of 5. Okay, just a few, maximum of 5. So yes, I'm expecting the report that you follow it, and I'll give you a maybe 1.5 weeks of time or 2 weeks of time. It's fine. Any questions? Nahari Prashadhatina? So our assignment requirement is also done. Harida. So next is revision. Revision is most important, but when we get our exam dates, we'll do a lecture for revision. Even නැතුව මේ දැන් revise කරලා තේරුමක් නැහැ. Then I'll give you your lecture slides, go through the slides, make notes. හරිද? දැන් ඒව කරන්න. ඔයගොල්ලෝ notes හදාගන්න slides එක print outs අරගෙන එහෙම තියාගෙන highlight කරගෙන එහෙම කරගන්න හරි notes ලියාගන්න කොහොම හරි තමයි note එකක් හදාගන්න දැනට slides තුන. Right? So when it comes to revision and when you in the revision I'll also share some papers also past papers with my share කරන්න ඒවත් try කරන්න at home. So we'll discuss one past paper, right? Then I can tell you what areas you should focus on more, right? And then also I know the content is too big. Then you have to, those numerical questions. ගණන් හදන ඒවා ටිකක් ආයෙ බලන්න. ඊළඟට මොනවද? Yeah. So I'll share the slides, then you can prepare your notes. Then we'll cover our lecture content within 2 more lectures. So we don't have much heavy content. Then we'll do a separate lecture for revision. Okay, when the exam time arrives. Anyway, if you have any questions, you can ask me, contact me. We can wind up for today, right?
Thank you, madam.
Thank you.
Okay.